This morning I tried to ask what I thought was a simple question. Do more people die from extreme heat or cold? And with a warming climate, will more or less people die? But it turns out the answer to this question is a bit more nuanced than I originally thought. The short answer is both heat and cold can kill, but cold is far more deadly. For every death linked to heat, 9 are tied to cold. But the complete answer is a bit more nuanced and complicated, so that's what we're going to be talking about throughout the course of this video. And by the end of it, hopefully we'll be able to answer the question, will global warming make temperature less deadly? So the scientific paper published in the June 2021 issue of the journal Natural Climate Change was alarming. Between 1991 and 2018, the peer review study reported more than 1/3 of deaths from heat exposure were linked to global warming. That's a pretty big number right there. Hundreds of news outlets covered the findings. The message was clear. Climate change is here, and it's already killing people. But that wasn't all that was happening. A month later, the same research group, which is based out of the London School of Hygiene and Tropical Medicine, but includes scientists from dozens of countries, released another peer-reviewed study that told a fuller, more complex story about the link between climate change, temperature, and human mortality. The two papers' authors were mostly the same, and they used similar data and statistical methods. So it's going to be interesting to see how the two studies differ. So published in Lancet Planetary Health, the second paper reported that between 2000 and 2019, annual deaths from heat exposure increased, but deaths from cold exposure, which were far more common, fell by an even larger amount. So in other words, while heat deaths increased, cold deaths decreased, and because cold kills more people, the overall deaths decreased. All told, during those 2 decades, the world warmed by about 0.9 degrees Fahrenheit, and some 650,000 fewer people died from temperature exposure. So right off the bat, that's not exactly what I expected to hear. I'd always thought more people died from heat, but what I think this article also goes on to say is that you hear more about heat deaths because they do have larger spikes. When you get a big heat wave, you can have a lot of deaths, but more people die in the winter because it is, I believe, just a lot harder on your body. And then this graph right here shows heat going slightly up, and then deaths linked to cold in millions, going from about 18.7 million to 17.7 million. And that's a lot of people dying from cold. I'd imagine some of those deaths aren't completely just cold deaths, but it's where cold impacted or made the death more likely. While it was not covered widely in the press, the second study circulated on Twitter, where many people made some version of the same argument. If cold was deadlier than heat, and the planet was getting hotter, global warming might actually save lives. But whose lives? Projections indicate milder temperatures may indeed spare people in the globe's wealthy north, where it's already colder and people can buy protection against the weather. Yet heat will punish people in warmer, less wealthy parts of the world, where each extra degree of temperature can kill, and air conditioning will often remain a fantasy. So that's where this becomes a bit more nuanced. It's not a simple, less people will die or more people will die. It depends on which region you're talking about, because there's varying levels of adaptation, and then there's also many varying climates. So what's at stake? Climate change is complicated. Scientists' worries about climate change go beyond temperature's effect on human mortality. Shifting weather patterns and rising sea levels could throw society and nature into disarray. Yet understanding climate change means studying all the changes, even the positive ones. Lives are not ledger entries. Doing arithmetic with human lives is ethically fraught. An elderly person living in Minneapolis might dodge an early death if dangerous cold grows rarer. Yet a construction worker in Phoenix, toiling in the heat wave, will find little comfort in a global drop in cold-related deaths. So science helps prepare for the future. Many species don't adapt well to temperature changes, but humans do. By examining where and when temperature will grow more dangerous, societies can ready themselves for the coming changes. So like Goldilocks, our bodies like things just right. And I actually just did a video on this morning where I looked up what's the healthiest weather for human beings, and it turns out it's 73 degrees and sunny. And the reason for that is it's very moderate, so you don't expend energy trying to moderate your own temperature. So more of your energy can go to just keeping yourself healthy. So too hot and our bodies work to cool down, which puts pressure on our hearts and kidneys. Too cold and our blood vessels constrict to keep our cores warm, slowing the flood of blood and oxygen to the heart. Extremes are dangerous, but unprotected exposure to even mild heat and cold over several days can be deadly. In most places, the temperature is more often too cold than too hot, which helps explain why more than 90% of temperature-related deaths were from cold, according to the Lancet study. On every continent, cold deaths surpassed heat deaths. And I'd say that last line was pretty surprising there, because I imagine on some of the continents that are notoriously hot, I would have thought that heat deaths would be more likely, but it looks like on every continent, cold deaths surpass heat deaths. So Twitter chatter notwithstanding, the Lancet paper did not conclusively prove that climate change led to a drop in temperature-linked deaths. It relied on just 20 years of data, and scientists require at least 30 years of observations to draw conclusions about climate change. Plus, its estimates came with great uncertainty, so what looked like a drop in cold-related deaths could actually have been an increase. And one of the hardest things to communicate as a scientist is uncertainty. So that is always an important thing to think about. And then it's also interesting what they said about the 20 years of data, because technically speaking, climate is the average weather over a span of 30 years. So I'm not sure why they would have picked a 20-year data set. Perhaps that's all that was available, but that is one, I'd say, caveat to this study. Still, it is at least plausible that, as the paper's authors put it, the results indicate that global warming might slightly reduce net temperature-related deaths in the short term. But what about the long term? A groundbreaking peer-reviewed study published in November in Harvard's Quarterly Journal of Economics gives us a glimpse. In the study, a team of researchers projected how mortality from temperature would change in the future. And there's some pretty good graphics to go along with this one. The worldwide temperature-linked mortality rate is projected to stay about the same, but you can see enormous geographic variation. Colder, wealthier countries do well, while hotter, poorer countries suffer. And here we can just look at this graphic. It looks like United States has a slight decrease. India has a slight increase in the number of deaths. And what we're looking at here is if temperature were to continue just based on emissions or the model run based on current emissions, if you were to compare that to how many people are dying right now and then look at the end of the century, how are different countries doing? So where you see the green, that's where there's actually a decrease in heat or cold deaths. And then where you see the blue is where there's an increase in deaths. So it looks like the colder countries actually do well with climate change, and then the warmer countries do poorly, which you'll see there's even a little bit more nuance to be had there. So the study's method worked like this. Imagine a future where the climate stayed as it was in 2015 and compare it to scenarios in which humans keep emitting greenhouse gases. The researchers used two emission scenarios, one with very high emissions, which has academic interest but is unlikely to actually happen, and a medium emission scenario, which climate scientists tell me is more likely if a touch optimistic. And again, that just depends on future emissions and what actually ends up happening, and how quickly we can maybe switch to sustainable energy. In the medium emissions scenario, Niger, one of the poorest and hottest countries in the world, is projected to suffer the largest increase in temperature-linked mortality, while cold, wealthy Finland sees the largest decrease. That pattern was common, said Michael Greenstone, a University of Chicago economist who co-authored the study. Greenstone, who over a decade ago helped the Obama administration calculate the social cost of carbon, a measure of the damages caused by each ton of carbon dioxide released into the atmosphere, was struck by the unfairness the results implied. Taking $100,000 from a poor person wouldn't be equal and opposite to how you feel about giving $100,000 to Elon Musk, he told me. I think that's the underbelly of the climate problem. The chart below shows the relationship between 199 countries' average temperature and how their temperature-linked mortality is projected to change by the end of the century. So just looking at this chart right here, where you see the green, that means it's good for those countries that were getting warmer. They have decreased mortality because you have less cold deaths. So it's a lot of the colder countries. And then where you see blue, that's where you have increased mortality, and that's where you have a lot of the warmer countries. And then another part of the reason you may have decreased deaths in the cooler countries is because of perhaps an increased ability to adapt. And I believe they start to talk about that next. What sets this work apart from similar studies is that its model accounts for humans' evolutionary superpower, adaptation. Of the millions of species on planet Earth, only one of them can turn on the air conditioner. If you have any friends who live in Seattle or the Bay Area, they don't really have air conditioning right now, but they're all going to, Greenstone said. The idea that they were just going to sit there every year, wait for the temperature to come and cause misery and destruction, and not do anything about it, violates everything we understand about human behavior. And we actually have seen this play out with some heat waves in the past, where 100 degrees up in Washington actually ends up leading to more deaths than 100 degrees in, let's say, Palm Springs. One aspect is because maybe the people are more used to those climates, but it's also because everybody in Palm Springs has air conditioning, while nobody, or I shouldn't say nobody, but far fewer people up in Washington do. And then what this is saying is that in the future, more people are just going to have air conditioning, so that would also help to reduce the heat-related deaths in countries that can afford air conditioning. Many studies that project future temperature deaths do not account for adaptation, not because they don't believe humans will adapt, but because adaptation is hard to quantify. And I've found this as a researcher. The hardest part about research is actually just collecting the data. Those studies are likely to overestimate the number of temperature-linked deaths because the people in them act more like coral reefs than humans. Something to think about if you're ever reading a future study. It's that the methodology is very important for how seriously you can take the findings. To account for adaptation, the researchers used a statistical technique that compares the behavior of people with similar incomes, but who live in places with different climates. It helps answer questions like, how much would it cost Seattle to learn to handle heat waves the way Houston does now? Christy Ebbe, an epidemiologist at the Center for Health and the Global Environment at the University of Washington, who is not involved in the research, has spent a lot of time thinking about questions like that. All heat-related deaths are preventable, and so we should be preventing every death we can from the heat, Ebbe told me. There's lots of mechanisms to do so. When Seattle endured a record-breaking heat wave last summer, I think that's the one I was just talking about, the county's regional homeless authority opened indoor cooling spaces, and the city's public utility agency had already filled the reservoirs to prepare for higher water usage. Across the city, air conditioners are selling fast, so that's part of adaptation. But Seattle is a high-tech city in a wealthy country. For much of the world, adapting to heat will be much harder. Adaptation is not something that just kind of happens when we're asleep by unicorns and elves. It takes policy and it takes money, says Andrew Dessler, a professor of atmospheric sciences at Texas A&M University who is not involved in the research. The people who are barely getting by today are not going to be able to adapt. Then they're not going to have the resources. That's what it should say. And so what are they going to do? Well, they're going to suffer. So what have we learned? It appears that more people die because of cold than heat. So over the next century, as temperature increases, overall, there will be fewer people dying due to temperature extremes. But there's a bit more nuance to that because it depends on which region you're talking about. In countries that are hotter and typically have a lower GDP per capita, there will be an increase in mortality because there will be an increase in heat-related deaths. Whereas on the other hand, in colder countries that on average have a higher GDP per capita, there will be a decrease in mortality because there will be a decrease in cold-related deaths and they have a larger ability to adapt.